Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Subramaniam with a PhD in Chemistry. So today we are going to continue with the second part of states of matter. Already I have finished the first part of the states of matter unit. You can go back and revise it and watch it again if you haven't seen the video. Okay, so before starting with the lesson today, I would like to answer a few questions which my student had asked me regarding the NEET exam. So the first question is, should you start with easy hard topics for revisions? Yes, you should start your day with the topics that require the most concentration. For example, if retention is not your forte, you should start your day with inorganic chemistry. If you have a problem with formula application, you should start your day with solving problems. Then work on topics which will fetch you marks potentially. I would not recommend starting any new topics now. For topics which are untouched till now, remember the basic formula and see the past year problem on these topics. So another question a student who had asked me is, how many hours in the day should you study? So the answer to that question is, do not overwork yourself. Remember, this is a marathon effort of 2 years. Thus, these few couple of months or days require you to be calm to apply the knowledge you have gathered in the last 2 years. A typical day should be divided into 4 slots, mainly one for mock test, 3 for each of physics, chemistry and maths. Then one more question which a student asked me was, what else can make your study more effective? My answer is, temperament is a game changer in all competitive examinations, and thus you should start the day with 10 minutes of meditation if you are interested in it. Also engage in 1 hour of any outdoor activity to unwind at some point during the day. I would recommend that you should start your day very early itself, if possible 4 to 5 a.m. I know most of you won't agree with me for getting up early, but that will be best, and wrap your studies. Also, don't sit too late into the night. Try your maximum to finish off early and go to bed early. Okay, so with that we will start with today's topics. So we were talking in our last session about Charles' law, Boyle's law, Avogadro's law, Gay-Lussac's law and all that. So today we will continue with Charles' law relationship. Okay, for a fixed mass at constant pressure, volume of a gas increases when temperature is increased and decreases on cooling. So they found out that for each degree rise in temperature, volume of a gas is increased by 1 by 273.15 of the original volume of the gas at 0 degrees Celsius. So if the volume of the gas at 0 degree and at T degree Celsius is V0 Vt, then we can write the relation like Vt is equal to V0 plus T by 273.15 V0. Vt is equal to V0 into, take the common factor 1 plus T by 273.15. Okay, now we can write like this. So at this stage we can define a new scale of temperature such that T degree Celsius on a new scale is given by capital T is equal to 273.15 plus small t, and 0 degree Celsius will be given by T0 is equal to 273.15. So this new temperature scale is called the Kelvin temperature scale or absolute temperature scale. It is also called thermodynamic scale of temperature. So we write T1 is equal to 273 plus small t, or T0 is equal to 273. In the equation we get Vt is equal to V0 into T1 by T0. Okay, now what is the relation of water density and molar mass of a gaseous substance? So ideal gas can be arranged as follows: N by V is equal to P by RT. Now when we replace N by M by M, we get M by MV is equal to or D rho. This is rho actually by RT. Okay, now M by V, this part is equal to D. So we can replace it by D by M is equal to rho by RT. For calculating molar mass, we can use this formula. Remember, M is equal to dRT by rho. Don't forget this formula. Okay, now Dalton's law of partial pressure states that total pressure exerted by a mixture of non-reactive gases will be equal to the sum of the partial pressures of individual gases. If you take a mixture of gases, pressure exerted by individual gas is called a partial pressure. For example, P total is P1 plus P2 plus P3 etc. The pressure of a dry gas is calculated by subtracting vapor pressure of water from total pressure of the gas which contains water vapor. So pressure of dry gas is equal to P total minus aqueous tension. So pressure exerted by saturated water vapor is known as aqueous tension. Okay, I think you understood this part. Now next, what is liquefaction of gases? So you can see in this figure the isotherms of carbon dioxide, and plotted the isotherms of carbon dioxide at various temperature, and it was found that all real gases they behave like carbon dioxide. So it was noticed that at high temperature gases cannot be liquefied. 30.98 degree carbon dioxide remains a gas up to 70 degrees Celsius. At 73 atmospheric pressure, liquid carbon dioxide appears for the first time. So remember that. Okay, next, when you divide P1 by P total, we get P1 by P total is N1 by N1 plus N2 plus N3 RTV. So N1 by N1 plus N2 plus N3 is equal to N1 by, we can take it as N, that is X1. So N is equal to N1 plus N2 plus N3. So therefore P1 is equal to X1 P total, where X1 and Pi and Xi are partial pressures of the gases. So you can use this formula to find the partial pressures of individual gases. Now what is the behavior of real gases? Do they deviate from the ideal gas behavior? So PV value will decrease after an increase in pressure and reaches to a minimum value, which is characteristic of any gas. And after the PV value then starts increasing, the curve crosses the line for ideal gas, and after that it shows positive deviation continuously. So it's found that real gas do not follow ideal gas equation perfectly under all conditions. So this should be actually the ideal gas, but they deviate from the normal properties. Okay, so here deviation from ideal gas behavior, it's become apparently pressure versus volume plot is drawn. So pressure versus volume plotting, like by taking experimental data for real gas, and it is calculated by using Boyle's law ideal gas, it should coincide. So it's very clear that at high pressure measured volume will be more than the calculated volume. The low pressures measured and calculated volume will approach each other, which is very clear from this gas. This is for real gas, the black one. The dotted line is for ideal gas. Okay, next one. So you know that real gases show deviations from ideal gas because the molecules of a real gas will interact with each other. So what happens at high pressure, molecules of the gases are very close to each other and they start interacting with each other. So high pressures, molecules do not strike the wall of the container with full impact because this will be dragged or pulled back by the other molecules due to molecular attractive forces. The pressure exerted by the gas will be lower than the pressure exerted by the ideal gas. So P ideal is equal to P real plus AN square by V observed pressure. This is the correction term. A is a constant term here. Okay, repulsive force becomes important, that is when the volume occupied by molecules instead of moving in volume V are restricted to V minus NB. NB is total volume occupied by the molecules. B is a constant term. So taken into account the corrections for pressure and volume, rewrite the equation like P plus AN square by V square is equal to V into V minus NB is equal to nRT. So PV is equal to nRT can be written as add this correction term here, subtract this correction term here. Okay, this equation is known as Van der Waals equation, which is very important. N is the number of moles of the gas, constants A and B, they are called the Van der Waals constant, and values depends on the characteristic of the individual gases. So value of A is a measure of magnitude of intermolecular attractive forces within the gas, and it is not dependent or it is not related with temperature and pressure. Now the deviation from ideal behavior is measured in terms of compressibility factor Z. That is what is the ratio of the ideal gas. So Z is equal to PV by nRT. For ideal gas, Z is equal to 1 for all temperature and pressure because of the ideal gas relationship. So graph Z versus P will be straight line which is parallel to the pressure axis, and if the gas deviate from ideality, Z value also will deviate from or change from unity. What happens at low pressure? All gases have Z is equal to 1 and behave like ideal gas. If Z is greater than 1, then the gases are difficult to compress. Z less than 1 at intermediate pressures. So gases show ideal behavior when volume occupied is large. So the volume of the molecules can be neglected in comparison. The temperature at which a real gas obeys all ideal gas laws, our appreciable change of pressure is called Boyle temperature, or it's also called Boyle's point. So these all are very important concepts. Please do take your time to read this properly and revise well. Now, what is the Boyle point depends on its nature, and above Boyle's point, real gases will show positive deviation from the ideality, and Z values are greater than 1. The attractive forces between molecules will be very low. Below Boyle temperature, a real gas shows decrease in Z value with increase in pressure when it reaches a minimum value. So if the pressure is further increased, value of Z also will increase continuously. So what is the derivation? Z equal to PV ideal by nRT. So if the gas shows an ideal behavior, then V ideal will be equal to nRT by P. Putting this value of nRT by P in the equation, we get Z is equal to V real by V ideal. Okay, now, so here you can see the compressibility factor is the ratio of the actual molar volume of a gas to the molar volume if it were an ideal gas at that particular temperature, and figure is can refer to the textbook also for the diagrams. And temperature 30.98 is called the critical temperature Tc of carbon dioxide. So highest temperature at which a liquid carbon dioxide can be observed is the critical temperature. So volume of 1 mole of gas at critical temperature is called critical volume Vc. Pressure at this temperature is called critical pressure Pc. Critical temperature, pressure and volume are called critical constants. A gas which is below the critical temperature, you can liquefy it by applying pressure. So that is also called the vapor of the substance. Now what is the liquid state? So if the vapor pressure at a stage where an equilibrium is established between liquid phase and vapor phase, that is known as the equilibrium vapor phase or saturated vapor phase. And the temperature at which vapor pressure of a liquid is equal to the external pressure, that is the pressure outside, is called the boiling temperature at that pressure. What happens at 1 atmosphere pressure boiling temperature? We call it normal boiling point. Pressure is 1 bar, then boiling point is called standard boiling point. Then a temperature when the density of the liquid and vapor are the same, that is the boundary between liquid and vapor disappear, that we call as critical temperature. Revise all these terms and don't forget it. Now surface tension, which you have already learned, is very simple and important. So if a molecule experiences equal intermolecular forces from all sides, molecules will not experience a net force. This phenomenon is called surface tension. So liquids tend to minimize surface area. Surface molecules will experience a net downward force which has more energy than molecules in the bulk. Surface of the liquid is increased by pulling a molecule from the bulk attractive force that has to overcome it. So the energy required to increase the surface area by 1 unit is defined as the surface energy. Okay, the SI unit is given here. Surface tension, we can define it as the force acting per unit length perpendicular to the line drawn on the surface of the liquid, denoted by a Greek letter like this, gamma. Now what is viscosity? Very important. Is the measure of the resistance to flow which arises because of the internal friction. That is, when the liquids flow, there are so many layers on top of the other. Between any two layers there will be some resistance to the flow, because when they slip past one another, so that is known as viscosity. So if a liquid flows over a fixed surface, then the layer of molecules in the immediate contact surface is stationary. The velocity of the upper layer will increase as the distance of the layer from the fixed layer will increase. So the type of flow in which there is regular gradation of velocity in passing from one layer to another is called laminar flow. If the velocity of the layer at a distance dz is changed by value du, then the velocity gradient can be written as du by dz. A force is required to maintain the flow of layers, and this force is proportional to the area of contact of the layers and the velocity gradient. And we know that F is proportional to A area of the cross section, so we can write like F is proportional to du by dz, F is proportional to A du by dz, or nu into A du by dz. When you remove the proportionality sign, it's known as a coefficient. This sign is known as a coefficient of viscosity. Please do write this derivation and learn. I've given it as simple as possible for all of you to understand. Now here you can see that viscous force like Na and delta Vx by dy. This is x and this is y. The units of viscosity are then Ns by meter square, or Pa second. Cgs unit, the dyne second per centimeter square, known as poise. And viscosity of water at 20 degrees Celsius is 0.01 poise. Viscosity of blood at body temperature is 0.03 poise. And PAS is called a poisson, it's equal to 10 poise. Okay, with that we are coming to this conclusion of this particular unit, and I hope you would have enjoyed learning this. When you read the textbook NCERT, you find it a bit complicated, but I've tried my maximum to make it simple and easy for all of you to learn. So, and Even all students, every student can find it very easy. And I'll be uploading the coming next few chapters immediately. Hope you all liked and enjoyed the video. Please do subscribe, share and like my videos and share it with your friends, and don't forget to press the bell icon so that as soon as I post my videos you will get the notifications immediately. With that, we are coming to a conclusion of today's session. Thanks for watching my video.